Many of us know how does an Earth look from outside, but does anyone know how Earth looks from inside and what is made up of? So today we are going to explain about the interior of the Earth. The Earth is made up of a series of layers. Center of the Earth is about 6,400 kilometers below the surface. Temperature and pressure increase inside the Earth's surface with the depth. The Earth is divided into three main layers. 1. The thin crust, brown portion, which support all life in the known universe. 2. The mantle, red. 3. The molten outer core, orange. 4. And the dense hot inner core, yellow. We will first discuss about the thin crust. Crust is the thinnest layer of the Earth, which is made up of silicon and aluminum 5 to 70 kilometers. The hard brittle crust extends from Earth's surface is called Mohorovičić discontinuity, which is nicknamed as MOHO. It is located below the seafloor and is about 35 kilometers beneath the surface of the continents. Crust is made of oceanic and continental crust, where oceanic crust is 5 kilometers thick beneath the oceans and continental average thickness is 5 to 40 kilometers. Continental crust is less dense than oceanic crust because it is made up of mix of light and dense rock types. Continental is made up of silicon and aluminum sedimentary and granitic rocks, whereas oceanic crust is composed of dense rocks basalt. Beneath the MOHO is the viscous layer that makes up more than half of Earth's volume. Lava comes from this layer. Now comes mantle of the Earth. The mantle is divided from the core by the Gutenberg discontinuity, about 2,880 kilometers beneath the Earth's surface. The outer core is molten and liquid iron and nickel, while the inner core is solid and much denser than either iron or nickel at the surface. Upper part of mantle is 100 to 1,700 kilometers. Consist of SiMa, silicon plus magnesium, and basic rocks. First 100 to 400 kilometers consists of a zone of weak rocks called asthenosphere. And the lower part is 1,700 to 2,900 kilometers, which consists of ultra-basic rocks. Mantle makes up a whopping 84% of Earth's total volume. The temperature of the mantle varies greatly from 1,000 degrees Celsius. The transfer of heat and material in the mantle helps determine the landscape of Earth. Activity in the mantle drives plate tectonics, contributing to volcanoes, seafloor spreading, earthquakes, and mountain building. The combination of the crust and this upper part of the upper mantle, which both are comprised of relatively cool and rigid rock material, is called the lithosphere. The lithosphere is the solid, outer part of the Earth, extending to a depth of about 100 kilometers (62 miles). The lithosphere includes both the crust and the brittle upper portion of the mantle. The lithosphere is both the coolest and the most rigid of Earth's layers. The most well-known feature associated with Earth's lithosphere is tectonic activity. Tectonic activity describes the interaction of the huge slabs of lithosphere called tectonic plates. The lithosphere is divided into 15 major tectonic plates: the North American, Caribbean, South American, Scotia, Antarctic, Eurasian, Arabian, African, Indian, Philippine, Australian, Pacific, Juan de Fuca, Caucasus, and Nazca. The division in the lithosphere between the crust and the mantle is called the Mohorovičić discontinuity, or simply the MOHO. The MOHO does not exist at a uniform depth, because not all regions of Earth are equally balanced in isostatic equilibrium. First 100 to 400 kilometers consists of a zone of weak rocks called asthenosphere. And the lower part is 1,700 to 2,900 kilometers, which consists of ultra-basic rocks. The asthenosphere is the denser, weaker layer beneath the lithospheric mantle. The temperature and pressure of the asthenosphere are so high that rocks soften and partly melting, becoming semi-molten. Finally, the core of the Earth. The core of the Earth is composed of mostly metal, therefore known as metallic core, which is made up of outer and inner core. Earth's core is the very hot, very dense center of our planet. The ball-shaped core lies beneath the cool, brittle crust and the mostly solid mantle. The core is found about 2,900 kilometers below Earth's surface, and has a radius of about 3,485 kilometers. Outer core is made up of Ni-Fi, that is, nickel plus iron. Composed of barosphere, heavy metallic rocks. Elements that dissolve in iron, called siderophiles, are also found in the core. Because these elements are found much more rarely on Earth's crust, many siderophiles are classified as precious metals. Siderophile elements include gold, platinum, and cobalt. The liquid metal of the outer core has very low viscosity, meaning it is easily deformed and malleable. The hottest part of the core is actually the Bullen discontinuity, where temperatures reach 6,000 degrees Celsius (10,800 degrees Fahrenheit), as hot as the surface of the Sun. The inner core is a hot, dense ball of mostly iron. It has a radius of about 1,220 kilometers. The inner core's intense pressure, the entire rest of the planet and its atmosphere, prevents the iron from melting. Geoscientists think that the iron crystals in the inner core are arranged in an HCP hexagonal close-packed pattern. The crystals align north-south, along with Earth's axis of rotation and magnetic field. The core will never freeze over. The crystallization process is very slow, and the constant radioactive decay of Earth's interior slows it even further. Scientists estimate it would take about 91 billion years for the core to completely solidify, but the Sun will burn out in a fraction of that time. Thank you for watching. Like, comment, share and subscribe.